Okay, so like Jim said, this particular breakout session has to do with knowledge modeling. So we'll talk a little bit about some of the learning points. The first one is the fidelity of evaluation. So we'll talk about what that means as we get into the demonstration, just making sure that we're kind of reducing the potential margin for error. We're able to then start to automate some things long term. We'll talk about things that we call output states. So we have columns and steps. We have two different types of knowledge models, and we'll talk a little bit about those, but we'll talk about columns within our value tables and steps within our methods, and those produce output states. Like I said, those columns and steps participate in value tables and methods. So the columns will roll up to produce an overall value table output state. The steps will roll up to produce an overall method output state. And as we start to develop these knowledge models, the objective here long term, like we said, is to increase the fidelity of evaluation, but then also allow for the automation of that knowledge evaluation. So reduce the manual effort required in evaluating. So now I'm going to go into a demonstration, and I think this will work. Can you see an assessment control, Jim?
We can, yes.
Perfect. So this is an assessment control. If you haven't seen one before, it looks very much like a checklist. There are a lot of different features associated with it. So I regularly get in trouble for calling it a checklist because it does much more than a typical checklist would do. But you have different information that needs to be evaluated. If you were in the session previously, we have context associated with this particular evaluation, and that's in the project. Then based on that context, we can deliver the right pieces of knowledge. These are just generic things with generic screenshots on them. And then we need to evaluate them. So are we green or are we red? So the first aspect of evaluation is just manual attestation, right? Someone comes in, they read the information, they say, on my project, we're all set with that. And they say we're green. Well, as we start to understand knowledge, and a lot of our organizations do understand the knowledge already, they have best practices, you have thresholds of minimums and maximums or ranges that we need to fall under, and those can be conditionalized. As we start to understand the information a little bit more, we can produce these knowledge models. So the knowledge model, and I'll open one up here as an example, can start to say, we have an input. We need to take that input, compare it to another value, and then that's going to produce our red or green. So if I come here, like we said, we have the rule is captured in a column. So that column is going to have its own output state. And then the entire knowledge packet or value table is going to inherit a rolled up output state from that column. So we know that we have a value. That value cannot be over 2.45. So we enter in a value of 3. And when we evaluate, we get a column output state of fail, and that rolls up because there's only one item into an output state of fail for the entire value table, for the entire requirement, best practice, audit question, lesson learned, whatever it might be that's captured in the knowledge packet. So instead of the user reading through, potentially misunderstanding, potentially misinterpreting, we can ask for a specific value. That value is put in, and then the knowledge model is going to evaluate the rule. So I'll just show if we put in a value that does fall within the boundary, we get a pass condition, and that updates our value table output state to pass as well. So now we have our knowledge model. We're going to put that into an assessment. Like we said, we're going to ask for our value here. We'll evaluate. You'll see it produces the pass conditions. And then because our community of practice has been configured to know that pass means green, our conformance is automatically set, and we're not coming and manually producing the green here that's on the status column. So if we continue to kind of go through that and open up some examples, we have another example of a knowledge model here. There's a lot of scenarios where there could be conditionality associated with a requirement. So in this particular scenario, we have a value that gets input, and then based on a condition, so this condition could be material type, it could be the region you're in, it maybe could be the product, it could be a lot of different things that can define when values or boundaries change. So in this particular scenario, we need to know what our condition is. I'm going to pick the first one. And then we need to know what our value is. And we get our past condition. I'm going to, oops, sorry. So we've got a minimum of 6 and 5. I picked the wrong value. Sorry about that. We're going to go 5 here. So our value is 5 and that passes. But if we change our condition, the value table knows that this requirement goes from 5 to 6. And there we can see our computed value is going to now produce a fail condition. Oops. So then our last example from a value table perspective is when we have certain scenarios where the boundary may be dependent on another input. So this is another example of conditionality, and that conditionality is going to impact the pass or fail condition. So here we'll enter in we evaluate, and then it produces the value for us. So there's a lot of different versatility in these value tables. We can take different numerical boundaries, we can take different conditional scenarios, and we can start to produce the information in these models. We can then start to remove the manual attestation. So instead of asking for pass fail, we ask for our values, and then the values are going to produce our conformance here on the left-hand side. As we start to produce these knowledge models, one of the things that we can then start to do, and you'll see some of this in the presentations tomorrow from Darwin, the presentation from the General Motors group about the CAD automation, is we can start to have these models interact with other resources and automate the evaluation of the knowledge. So instead of someone coming in and manually providing the value, the system can go out, it can retrieve the value from a CAD file, for instance, it can retrieve it from other systems within an organization, and then those pieces of information can be automatically evaluated without requiring the input from individuals. What that allows us to do is reduce the manual effort for communicating the values, and then we can start to focus our time and effort on potentially solving problems when we have, red statuses or problems that get encountered, those kinds of things. So the idea behind these knowledge models is to reduce the manual attestation associated with evaluating knowledge, start to produce these robust models that allow us to capture data in a normalized format, and then eventually what we want to do is be able to automate the application and the evaluation of that knowledge through different AI techniques or resources and connections within an IT infrastructure. So we kind of went through this one in a quick amount of time. I guess, are there any, if I come back to the presentation, there's a slide that says questions. I guess, does anyone have any questions about the concept behind knowledge modeling?
Thanks, Josh. Yeah, we do work pretty quick. We got some time for questions. So please, if anybody has any, put them in the chat box. Nancy has one. Nancy, thank you for your question. She's asking, Josh, what is your best practice recommendation for the company to maintain the knowledge model? Examples being rule changes, value range changes, etc.
Yeah, it's a good question, Nancy. There's a couple different things that I think are important when it comes to maintaining the knowledge base. We have different, I guess, roles within the software, roles within the concept of knowledge aware. And one of those roles is a subject matter expert. They're typically responsible, and they could be responsible for a lot of things, but one of the things that they're responsible is maintaining the knowledge base. Well, the knowledge packet allows us to make updates to the knowledge base. We have, version control, and we can make different revisions so that the places that it's been applied in the past are still maintained and the historical data is accurate and visibly what it was when the evaluation took place. But then anything moving forward is going to inherit or access the up-to-date information. So I'd say the best practices would be, one, use knowledge packets, understand how to use the version control and update them so that certain information can be preserved over time. But another aspect of that that's really important is having someone that is responsible for maintaining that knowledge. Obviously, we don't want that to be a significant amount of time or a significant responsibility, I guess is the wrong term, but we don't want it to require a lot of effort. So the knowledge packet has a lot of features that allows us to do that in an efficient way. But having someone that is defined as responsible for maintaining that knowledge, we find is generally the most effective way to do it.
Thanks, Josh. Thanks, Nancy, for the question. I'm glad that it seems like it answered what you were looking for. Keenan, thank you. He's got a question. So a knowledge model essentially sets numeric limits from attributes of a knowledge packet and based on the values determines green or red?
That would be correct. Yeah. So we want to start to understand what are the boundaries. The examples we had here are numerical limits. We do have other things that could be conditionalized. So we have an example that is not in this demonstration where we had a group that was dealing with ergonomics, and they were trying to understand, based on certain positions of a vehicle as it goes down an assembly line, what were the different access points and what conditions were in place that would allow you to efficiently adhere one part to the next. So they had a number of different questions that would get asked. Those questions would get answered, and it would say, okay, if you're going to do that, you need to put a safety glove on your hand. So it's not only numerical values, conditionality, decision model type of information can also be captured in these knowledge models.
Yeah. Thanks for the question, Keenan. Glad Josh answered that one. And thank you both, Keenan as well as Nancy, for the questions. If there's any other ones, please put them in chat. We've got some time for more questions if there is any. While we're waiting on that, Paula had a question. Thanks, Paula, for another question. Really appreciate your interaction today. She's asking, how does knowledge modeling provide tacit versus explicit knowledge, or tacit versus explicit knowledge? How do you reduce the amount of time and documentation updates, yet provide knowledge to assess a new technology?
Yeah, that is a good question. And I always get tacit and explicit knowledge confused. Okay, so reducing the amount of time in documentation updates, but providing knowledge to assess new technology. I guess I'm not completely following the knowledge to assess new technology, but okay, sorry. So the difference between the tacit and the explicit knowledge is a lot of times the tacit knowledge is where we would use the knowledge packet to capture that because it isn't known. It isn't somewhere where you could actually model it in a lot of scenarios. It's maybe like a best practice or a tip or trick for people trying to complete an activity. And the knowledge packet, when we open it up, let me share my screen again. It gives you the ability to not only capture the model itself, but also capture background information that could be best practices that are based on experience, but not necessarily fact. So that's one way that we can do it. The other thing that the knowledge packet is going to do is it's also going to collect all the data of how things have been applied in the past. So experience, best practice, information that might not necessarily be fact, but could potentially be other applications of knowledge. The KPAC, because it's that centralized gold source of information, it kind of collects all that information together, and it gives users access to it within the flow of completing the assessment that they have here. And then let me see what Paula's next question was. I'm not sure I know what the new technology is. It just like if you have maybe a new product that you're developing, if that's the case, then a lot of times typically we'll have knowledge that moves into the assessment control. That knowledge is then, we have scenarios where users will put like not applicable. So maybe that knowledge could apply. You see if it does. And as you go through the assessment control, start to understand what things do apply to the new technology, the new product, and which things don't. And then that data footprint can be established in a similar way to the greens and reds. We can also have not applicables. And over time, we can start to refine the delivery mechanisms so that it only delivers the applicable knowledge into evaluations of that new technology as it evolves over time.
Paula, let us know if you need any further detail or if that did or did not answer your question. We really appreciate your interaction. While we're waiting on that or any additional questions too, Joe Beth brings up a great point for everybody. The cool KPAC competition we have every year is tomorrow. And if you have a chance to sit in on that, you'll see some very interesting ways where people are actually modeling knowledge and using it in their processes today. Okay, Paula, thanks. I'm sorry you dropped for a bit, but I'm glad that answered your question. If you have any follow-up, you can reach out to Josh directly at any time or send us an email or something during or after the conference. We're here at your service, of course, for anything that we might need.